Hello dear subscribers. Today we will learn about electric motors. An electric motor is a device for converting electricity into rotational motion of a rotating part of an electrical machine. Energy conversion in motors occurs due to the interaction of the magnetic fields of the stator and rotor windings. These electric machines are widely used in all industries, as a drive for electric vehicles and tools, in automation systems, home appliances, and so on. There are many types of electric motors, differing in principle of operation, design, performance, and other features. Consider the main types of these electrical machines. According to the principle of operation, magneto-electric and hysteresis electric machines are distinguished. Despite the simplicity of design, high starting torque, the latter are not widely used. These motors have a high price, low power factor, limiting their application. The vast majority of manufactured electric motors are magneto-electric. According to the type of supply voltage, there are DC electric motors, AC motors, universal electrical machines. By design, electric motors are distinguished with a horizontally and vertically located shaft. In addition, electrical machines are classified according to purpose, climatic design, degree of protection against moisture and foreign objects, power, and other parameters. Motor classes: direct current, brushless EC, electronically commutated, with brushes, with sequential excitation, with parallel excitation, with mixed excitement, with permanent magnets, alternating current, universal, synchronous, induction, single phase, three-phase. DC motors. DC motors are widely used as a drive for electric transport, industrial equipment, as well as a microdrive for actuators. Such electric machines have the following advantages: the possibility of adjusting the rotational speed by changing the voltage in the excitation winding. At the same time, the torque on the DCT shaft, DC motors, remains unchanged. High efficiency for DC machines is somewhat higher than for the most common AC induction motors. With partial load on the shaft, the efficiency DPT is higher by 10 to 15%. Possibility of manufacturing DPT of small dimensions. Almost all used microdrives are designed for direct current. Simplicity of control schemes. Starting, reversing, and speed and torque control do not require complex electronic equipment and a large number of switching devices. Ability to work in generator mode. Electric motors of this type can be used as direct current sources. High starting torque. DPT is used in the composition of electric drives of cranes, traction and lifting mechanisms, where it is required to start under significant load. DPT is distinguished by the method of excitation. They are with permanent magnets. These engines are small in size. Their main area of application is microdrives. With electromagnetic excitation. Electric machines with electromagnets of this type are most widely used. They are classified according to the method of connecting the stator winding. Motors with parallel excitation. The armature and stator windings in this type of electrical machine are connected in parallel. Such electrical machines do not require an additional power source for the field winding. The rotor's speed is practically independent of the load. They are used to drive machine tools and other equipment. Electric motors with a series-connected stator winding. DCTs of this type have a significant starting torque. They are used as a drive for electric transport and industrial installations with the need to start under load. Motors with independent excitation. To power the stator winding of such electric machines, an independent DC source is used. DPTs of this type are distinguished by a wide range of speed control. Electric machines with mixed excitation. The excitation solenoid in such engines is divided into two parts. One of them is connected in parallel, the second in series with the armature winding. Electric machines of this type are used in machinery and equipment where high starting torque is required, as well as variable and constant speed with variable torque. Asynchronous motors. Due to the low cost and simplicity of design, electric machines of this type are widely used. Their fundamental difference is the presence of the so-called slip. This is the difference between the frequency of rotation of the magnetic field of the stationary part of the electric machine and the speed of rotation of the rotor. The voltage on the rotating part is induced by the alternating magnetic field of the motor stator windings. Rotation causes the interaction of the field of electromagnets of the fixed part and the magnetic field of the rotor, which arises under the influence of eddy currents induced in it. According to the features of the stator windings, there are single-phase AC motors. Motors of this type require an external phase shifter to start. It can be a starting capacitor or an inductive device. The scope of single-phase motors is low-power drives. Two-phase electrical machines. Such motors have two windings with phases shifted relative to each other. They are also used for home appliances and low-power equipment. 3. And multi-phase electric motors. The most common type of asynchronous machines. Electric motors of this type have from 3 or more stator windings shifted in phase by a certain angle. According to the design of the rotor, asynchronous electrical machines are divided into motors with a squirrel cage and phase rotor. The rotor winding of electrical machines of the first type consists of several uninsulated rods made of copper or aluminum alloys, closed on both sides by rings, squirrel cage design. Asynchronous motors of this type have the following advantages. A fairly simple startup scheme. Such electrical machines can be connected directly to the electrical network through switching devices. Permissibility of short-term overloads. Ability to manufacture high-power electrical machines. This type of motor does not contain sliding contacts that prevent power buildup. Relatively easy maintenance and repair. Asynchronous electric machines have a simple design. Low price. Asynchronous type motors are cheaper than synchronous machines and DC motors. Electric machines with a squirrel cage rotor have their drawbacks. The rotation speed limit is 3000 RPM or less when entering synchronous mode. Technically complex implementation of speed control. High starting currents at direct start. Electric motors with a phase rotor are partially devoid of the disadvantages inherent in machines with a squirrel cage rotor. The rotating part of an electric machine of this type has windings connected in a star circuit. Voltage is supplied to the winding through 3 contact rings fixed on the rotor and isolated from it. Such electric motors have the following advantages. Possibility to limit starting currents with the help of a resistor included in the circuit of the rotor electromagnets. Larger starting torque than electric machines with a squirrel cage rotor. Ability to adjust the speed. The disadvantages of such engines are relatively large dimensions and weight, high price, more complex repairs and maintenance. AC synchronous motors. As in asynchronous motors, the rotation of the rotor in synchronous machines is achieved by the interaction of the fields of the rotor and stator. The rotor speed of such electrical machines is equal to the frequency of the magnetic field created by the stator windings. The winding of the fixed part of the motor is designed to be powered by 3-phase voltage. A constant voltage is connected to the electromagnets of the rotor. Distinguish between salient and non-salient pole windings. Low-power synchronous motors use permanent magnets. The start and acceleration of a synchronous machine is carried out in an asynchronous mode. To do this, the motor rotor has a winding of the squirrel cage design. DC voltage is applied to the electromagnets only after acceleration to the nominal frequency of the asynchronous mode. Synchronous motors have the following features. Constant rotation speed with variable load. High efficiency and power factor. Small reactive component. Overload tolerance. The disadvantages of synchronous motors include high price, relatively complex design, difficult start, The need for a constant voltage source. The complexity of adjusting the speed of rotation and torque on the shaft. All the shortcomings of AC electrical machines can be corrected by installing a soft starter or a frequency converter. The rationale for choosing one or another device is due to economic feasibility and the required characteristics of the electric drive. Universal motors. In a separate group, universal electric motors are distinguished, which can operate from an alternating current network and from direct voltage sources. They are used in power tools, household appliances, as well as other low-power devices. The design of such an electric machine does not fundamentally differ from a DC motor. The main difference is the design of the magnetic system and the rotor windings. The magnetic system consists of sections isolated from each other to reduce magnetic losses. The rotor winding of such a machine is divided into two parts. When powered by alternating current, only half of it is energized. This is done in order to reduce radio interference, improve switching conditions. The benefits of these machines include high rotation speed. Universal electric motors develop speeds up to 10,000 RPM and more. Powered by AC and DC voltage. Engines of this type are widely used for power tools with additional batteries. Ability to control the speed without the use of additional devices. However, such electric machines have their drawbacks. Limited power. The need for maintenance of the collector node. Severe switching conditions when powered by AC voltage due to the presence of a transformer connection between the windings. Electromagnetic interference when connected to AC power. Each type of engine has its own advantages and disadvantages. The choice of an electric machine to drive any equipment is made on the basis of operating conditions, the required speed, economic feasibility, type of load and other parameters. Dear friends, I hope today's video was useful for you. Thank you everyone, stay healthy.